Hi, I'm Dr. Hay. This video is about Ohm's Law and resistance. So we're going to define current, I, as the change in charge over the change in time. In other words, charge passing per time. Now you can imagine this as charges like water particles, for example, flowing through a pipe. The pipe has some cross-section. Think of them as all these little positive charges flowing in a pipe. So this is current in a wire, for example. Now, it's actually the electrons flowing the other way that makes the current flow positive. We are calling current positive. This is current I. But we can think of it as positive charges moving to the right. Now, the units of current, notice this is coulombs per second. So a coulomb per second is equal to what we're going to call an ampere, A. Now, if potential drops over a passage of the wire, over the passage of this wire, then you're going to have some difference in potential here. So let's say it goes from VA and it drops during the course of its traveling in this wire to the value VB. I'm going to define the potential difference here as VA minus VB. Now, if this drops, then you have a resistance. You must have some resistance in this wire. And the resistance is defined as R equals V over I, the current I. Now, if I rearrange this, then I get the more familiar Ohm's law. And the units of resistance are actually called an ohm. An ohm, which is written like that. So let's say that the resistance passes through some segment of wire, and the segment, let's call that segment length L. So it reduces its potential by this much over a distance L. And let's say that it has a cross-sectional area A. So our wire has a cross-sectional area, and we define that cross-sectional area as A. That's not the same as the ampere. This is a cross-sectional area. Now, the wire also has a property called resistivity. Now, this property is labeled as rho. Rho is the resistivity. Now, it's a property of the material. It's also affected by temperature. So you can look up tables of rho. The resistance, R, is defined as rho L per cross-sectional area A. Rho has units of ohm meters. Okay, so now we can write our potential across a distance of wire because we've defined the resistance and placed it into Ohm's law.